Now let's describe how Stefan Boltzman law can be derived from Planck's law. The Stefan Boltzman law states that the total energy emitted per unit area per second from a perfectly black body is proportional to the fourth power of its absolute temperature. So here, as you can see, I have written this is the Stefan Boltzman law. E is equals to sigma T to the power 4, where sigma is the Stefan Boltzman constant. Okay, so let's proceed. Here I have written the total energy density of a radiation emitted by a black body is given as this one. Let me remind you, the Planck's formula states that energy density is equals to h by hc by lambda to the power 5 1 by e to the power hc by lambda kt minus 1 d lambda. So that was the Planck's formula, and this energy density we can write in this form: h by h by c cube integrating 0 to infinity nu cube d nu by e to the power h nu by kt minus 1. So after integrating we get this term h by c cube into kt by h integration 0 to infinity x cube dx e to the power x minus 1. Where this x is the h nu by kt, and differentiating x dx becomes h by kt d nu. So how this will help in further deriving this formula, let's see. Now we are integrating the right hand side, that is this part. So here we are applying the formula u by v. Differentiating we get x integration 0 to infinity x cube e to the power minus x plus e to the power minus 2x plus e to the power minus 3x plus and so on dx. So this thing we can write as summation p integration 0 to infinity x cube e to the power minus px dx. It becomes summation p 3 factorial by p to the power 4 is equals to pi to the power 4 by 50. In this derivation we have seen that 1 by e to the power x minus 1 becomes this one. So since e to the power x minus 1 inverse equals to e to the power minus x 1 minus e to the power minus x inverse, this one, and summation of p is equals to 0 to infinity 1 by p to the power 4 is equals to pi to the power 4 by 90. So E nu, that is energy density, becomes h by h by c cube k to the power 4 t to the power 4 by h to the power 4 pi to the power 4 by 15, and simply we can write this as a t to the power 4, where a is this term h pi to the power 5 k to the power 4 by 15 c cube h cube, which is constant. So for better understanding I have already written here that it can be shown that for any blackbody radiation, the amount of radiant energy passing through unit area in space filled with radiation in unit time at the same temperature, which is actually the Stefan's law. This is RT is equals to CA by 4 T to the power 4, which is sigma T to the power 4. Since A is this value, so sigma, that is the Boltz's constant, is also equal to this. So from here we can find the value of the Stefan constant, that is sigma is equals to C into A by 4 is equals to 2 pi to the power 5 k to the power 4 by 15 c square h cube, which is 5.67 into 10 to the power minus 8 Weber per meter square k to the power minus 4. So that was all the derivations related to blackbody theorem. and you have seen that how this black body radiation made the greatest invention in physics ever, that is this quantum mechanics. It has been observed that the experimental distribution curve for black body radiation agrees excellently with that of the theoretical distribution curve for all possible wavelengths. So, the success of Planck's hypothesis is to explain the distribution of energy spectrum of a blackbody radiation was the birth of actually the quantum mechanics. So that's all for blackbody radiation. In the next video we will continue with the further topic, which is the Compton effect.